Now we're going to be taking a look at synthetic division. This is a much simpler process for dividing polynomials. However, it does not always work. If we are going to be using synthetic division, we must have a divisor that has x to the first power, and it can only be two terms, which means it's a binomial, which is why it says linear binomials, meaning it'll look something like this: ax plus b. Examples where it would work again as the divisor would be x plus 2, 3x minus 1, something like that. If the divisor looks something like this, how about x squared plus 5x? Or x squared plus 5x plus 1, x cubed minus 2, just x cubed. Anything like that. These are quadratic or cubic functions. Anything with more than two terms or just less than two terms, this would not work for synthetic division. For example 2, it would like for you to circle all the situations in synthetic division can be used. Go ahead and pause the video and circle what you believe to be the correct answers and hit play when you are ready. Because the divisor is x minus 3 here, that is a linear function because it has a power of 1 and it's a binomial, so we could use it there. We cannot use it here because the divisor has something cubed. For this next one here, the power on the x is a 1 and there's two terms, so yes, this will work. Same with this one right here because it's linear and there's two terms. Again, linear and it's two terms. And here this is a quadratic binomial, so that would not work. For synthetic division, it has the same step 1 as long division. We need to make sure that the dividend is written in standard form and insert any placeholders. The placeholders are so important. If you do not put the placeholder, you will not get the correct answer. We would put the coefficients of our dividend here in the first row. So my coefficients are 6, a positive 7, and a positive 2. So I'm going to put a 6, a 7, and a 2. Notice how I did not put any placeholders because it was in standard form and I was not missing any terms. There's an x squared, x, and a constant. Then we need to put a number here. In order to get that number, we just set the divisor equal to 0, so 2x plus 1 equal to 0, and we solve. So 2x, I'm going to subtract 1 from each side, leaving me with negative 1, and then divide each side by 2. I get x equals a negative 1/2. So negative 1/2 goes here. In synthetic division, the first thing we do once we have it set up is we bring down the first coefficient. So I'm going to put a 6 here. And then we're just going to repeat the same pattern where we multiply the numbers down here by the number right here, which is negative 1/2, and then we would add. So once I bring down the 6, I'm going to multiply by a negative 1/2. That would become a negative 3. And then I'm going to add these two numbers together. So 7 plus a negative 3 would be a 4. Once again, I'm going to take this number down here and multiply by the negative 1/2, which would give me a negative 2. And then I'm going to add those two numbers together, which would give me 0. Your last number will be your remainder. And when we write our quotient, which is our final answer, we have these numbers here as our new coefficients. And our new coefficients will have powers 1 less than what we started. So originally we had an x squared, Now this is going to be 6x to the first power, or just 6x, plus 4, and then if I had a remainder, it would say plus that remainder over the divisor. It's worth mentioning that whenever you have a remainder of 0, that means the negative 1/2, the number that was right here, is a factor or a solution, meaning it's an x-intercept on the graph. When the remainder is not 0, we would use what's called the remainder theorem, which just essentially says that we would write our answer as a coordinate. I'll show you what that looks like later on in the problems instead of reading all of that. Let's practice synthetic division again because it can be confusing at first and we're just going to have to get the hang of it. So I'm going to draw this L shape right here. And in the first row, I need to write the coefficients of the dividend. We need to always make sure we are checking for placeholders and that it is written in standard form. This is currently written in standard form when I look at example 4. However, I do notice that I am missing an x squared term. So when I plug in my numbers, the coefficient of x to the 4th power is 1. X cubed has a coefficient of -2. There is no x squared. I am missing that. The coefficient for the x is 3, and then I have the constant, which is 1. The number that goes here is the divisor set equal to 0. So I would add 3 to each side, giving me a positive 3. Once we have it set up, we need to first bring down the 1. And then we're going to repeat the pattern of multiplying, adding, multiplying, adding. 1 times 3 is 3. -2 plus 3 is 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 9 plus 3 is 12. 12 times 3 is 36. 36 plus 1 is 37. Remember, our last number is going to be our remainder. I'm just going to put a little box around that to remind myself. And this would be my new coefficients. So we need to write it with 1 power less than what we started, because think about it. We have x to the 4th power divided by x. X to the 4th power divided by x is the same as x times x times x times x over x, where one of them would cancel, which is why we're starting now with x cubed. So my quotient is x cubed plus x squared plus 3x plus 12. And then the remainder we need to write over the divisor. So plus 37 over my divisor of x minus 3. Let's try it again. Example 5. I need to check that it is written in standard form and that if I see anything that's missing, I need to put a placeholder of 0. So I see 4, 3, 2, 1, awesome. The only thing that I'm missing is a constant, a number at the end. So I will have to put a 0 at the very, very end. Meaning it would look like, after I draw the L shape, 2, 14, -2, -14, and again, I'm putting that 0 because I don't have a constant there. The number that goes on the outside is going to be the divisor set equal to 0. So x plus 7 equals 0. To solve that, we would subtract 7 from each side, leaving me with x equals -7. Synthetic division, you bring down that first number, and then we multiply, add, multiply, add. -7 times 2 is a -14. Negative 14 plus negative 14 is 0. 0 times negative 7 is 0. Negative 2 plus 0 is negative 2. Negative 2 times negative 7 is 14. Negative 14 plus 14 is 0. 0 times negative 7 is 0. 0 plus 0 is 0. So now, these are my new coefficients. I started with x to the 4th power, which means now I'm starting with 2x cubed. I have 2x cubed plus 0x squared minus 2x plus 0. And I have no remainder, so I don't have to write anything there. This is not the simplest form. I honestly would just leave it as 2x cubed minus 2x. That's our final answer. Let's try it once again. Example 6, we need to set up our synthetic division. It is already in standard form. There's 3, 2, 1, and then there's the constant there. So I don't have to put any placeholders either. It's 3, negative 2, 1, negative 4. And then the number that I put on the outside is the divisor equal to 0. So that would be a positive 2. Bring down the 3. I need to multiply. 2 times 3 is 6. I add. That gives me 4. Multiply 4 and 2 gives me 8. I add, giving me 9. 9 times 2 is 18. And then I just need to add here, which gives me a positive 14. That 14 is my remainder, which means the quotient, I started with a cube, so now I'm going to have a squared. It's 3x squared plus 4x plus 9 plus 14 over the divisor x minus 2. I would like you to try examples 7, 8, and 9. When you are done, I would like you to resume the video and check your answers with my work. Here you can see examples 7 and 9. Example 7 did not have any placeholders and it was already in standard form. I ended up with a remainder of 0, so I didn't have to put a fraction at the end. This should have been my final answer. In example 9, there was a remainder, so I did have to write the remainder over the dividend. You could have put plus negative 28 here, or written it as minus 28 over the divisor like I did. And now I'm going to scooch it over so you can see example 8. For example 8, you actually had 2 placeholders. And this was my final answer right here.